Here's problem 37-7. Two slits are illuminated with green light, wavelength of 540 nanometers. The slits are 0.05 millimeters apart, and the distance to the screen is 1.5 meters. At what distance in millimeters is the average intensity 50% of the central maximum? So we have a wavelength of light of 540 nanometers. We're told that the slit distance is 0.05 millimeters, and the distance to the screen is 1.5 meters. And we basically want to find y. Now we know in general that the intensity of the pattern is equal to the maximum intensity times the cosine squared of pi dy over lambda L. And in this case, we're told that intensity at this point is equal to 50% of the maximum. So if we compare these two equations, we can get rid of the maximum, and we have that the cosine square of pi dy over lambda L is equal to 0.5. If I take the square root of both sides and the inverse cosine, I would have that pi dy over lambda L is equal to the inverse cosine of the square root of 0.5. When I take that inverse cosine, I better make sure that I am in radians mode when I do that calculation. So radians mode of my calculator. I'm going to solve this for y. In other words, y will equal lambda L inverse cosine of the square root of 0.5 over pi times d. Okay, so we have y is equal to the wavelength. 540 nanometers is 5.4 times 10 to the minus 7 meters times L, which is 1.5 meters, times the inverse cosine of 0.5, which is 1.047. Oops, I didn't take the square root of 0.5. .785. Over pi times d, which is 0.05 millimeters. And what do we get if we multiply all this? I get 4.05 times 10 to the minus 3 meters. Or if I wrote that in millimeters, which is what they asked for, that would be 4.05 millimeters. So the distance to the point on the screen, which is 50% of the central maximum, is 4.05 millimeters.